7.2 is about secants and tangents of circles. The theorem we learned today is written at the top. A radius is perpendicular to a tangent at the point of tangency. So what that's referring to is if you draw a radius of a circle and a tangent line is drawn through that point on the circle, then the radius is automatically perpendicular to that tangent. In problem number 1, we have a radius of 7 out to this point on the circle at the bottom, and there's a tangent line coming in. Now the segment here is labeled with 24. So that's your tangent, and 7 is labeling your radius. So automatically there's a right angle here because those two segments will be perpendicular at that point of tangent. That makes this triangle a right triangle. So with a leg of 7 and a leg of 24, the hypotenuse of that triangle will be 25. Number 2, we have a radius drawn in to a tangent line labeled with a 24. Automatically we know they're perpendicular, and that creates a right triangle. This 24 is on the leg and 26 is on this hypotenuse of the triangle. This is a 5, 12, 13 triangle. 24 is like 2 times 12. 26 is like 2 times 13. So there's the 12 and there's the 13. So this missing one is going to be 2 times 5 because we have a 5, 12, 13. So the answer for this one is 10. Number 3, draw in the right angle at that point of tangency. Now we see a right triangle. The leg we have is 6. The hypotenuse is 8. This is not a 3, 4, 5 triangle. If it was, the 8 would be on the leg. So we need to work out Pythagorean theorem. 6 squared plus a squared equals 8 squared. A squared equals 28. Therefore, a is 2 root 7. The missing leg is 2 root 7. Number 4, there's a right angle where this radius is touching the tangent. That creates a right triangle. This is not a special right triangle, so we'll set up Pythagorean theorem. 4 squared plus 6 squared equals c squared. 4 squared plus 6 squared is 52, and you have to take the square root of 52. You have to simplify that. You will get 2 root 13. That's the length of the hypotenuse. Number 5, we do have a tangent segment here again. Draw in the right angle there at the point of tangency. Notice how we have a 45-degree angle this time. That means we have a 45, 45, 90 triangle. And the first thing we're going to do is find the length of the tangent segment. Well, the tangent segment is a leg of that 45, 45, 90. The other leg is a 1. So those legs are going to be congruent. The answer to the first question is 1. Now we need the length of secant segment OE. OE is our secant segment, and that's also the hypotenuse of the 45, 45, 90. And if you recall, you're going to multiply the leg by the square root of 2 to get the hypotenuse. So 1 times the square root of 2 is just the square root of 2. Number 6, we have a tangent segment here. Draw in the right angle for the point of tangency, and that creates a 30, 60, 90 triangle. The leg of 1 is across from the 30-degree angle, and that is the short leg. Multiply the short leg by root 3 to get the long leg, so the long leg is root 3. Multiply the short leg by 2 to get the hypotenuse, so PE has a length of 2. Tangent segment EI is root 3, and the secant segment has a length of 2, or what I keep calling the hypotenuse has a length of 2. Now it's your turn. Work on 7 through 10 on your own. So pause the video, work on 7 through 10, then turn the video back on to check your answers. Number 7, I'm going to draw in the right angle. I have a 30, 60, 90 triangle. The 1 on the leg is across from the 60-degree angle, so that's the long leg. I'm going to divide by root 3 to get the short leg. When I divide by root 3, that's 1 divided by root 3. And remember, you have to rationalize the denominator. So I'll get root 3 over 3 as the length of segment LF. Root 3 over 3. Now I'm going to go from that short leg, root 3 over 3, and multiply by 2 to get the hypotenuse. So that will get me 2 root 3 over 3. Number 8, right angle at point R. This is a 45, 45, 90. So this leg is also 5. So the hypotenuse is 5 root 2. So the tangent segment, FR, has length 5. And the secant segment, or the hypotenuse, has length 5 root 2. Draw a right angle at point E. We have a 30, 60, 90 triangle. 4 is across from the 30-degree angle, so it's the short leg. Multiply by root 3 to get the long leg. And the hypotenuse is 8. So the tangent segment NE has a length of 4 root 3. And the secant segment, which is the hypotenuse, has a length of 8. And number 10, when I draw the right angle in, that gives me a 30, 60, 90 triangle. 9 is the long leg. I'm going to have to divide by root 3 to get the short leg. So 9 divided by root 3, multiply top and bottom by root 3, 9 root 3 over 3. But that reduces. 3 goes into 9 3 times. The short leg is actually 3 root 3. To get the hypotenuse, I'm going to multiply that by 2, so I'll get 6 root 3 for the hypotenuse. We have another vocabulary word to introduce, and that is concentric circles. Concentric circles are circles with the same center, but they have different radii. So here's an example of 4 concentric circles. Let's do an example. Let's draw 2 concentric circles with radii 16 and 34. So you're basically drawing something that looks like a donut or a Cheerio, and I'm going to draw in a little radius here and tell you that's the one with a 16. And then here's the radius of 34. We're being asked how long is a chord of the larger circle that is tangent to the smaller circle. A chord in the larger circle would connect 2 points on the circle, but I also want it to be tangent to the smaller circle. I'm going to aim for that radius, that 16 right there, and I'm going to make a tangent. So see that line I'm drawing in is tangent to the little circle? Then just make sure it connects up with the bigger circle. And that is a coincidence that my radii turned out so nicely. And so the tangent chord that you see is going to create a right angle right there where it's tangent to the little circle. And we know one leg of this right triangle is 16. What is this 34? Can you tell that this 34 is also the hypotenuse of the right triangle? This is actually a triple. The leg of 16 is 2 times 8, and the hypotenuse of 34 is 2 times 17. So this is an 8, 15, 17 triangle. This leg here is 2 times 15, or 30. And if this half of the chord is 30, then this half of the chord is 30. So the full chord is a total of 60 units long. Okay, let's do that again. I have the drawing here for you already. In number 11, draw in the radii. When you draw in the small radius, make sure it goes straight to that point of tangency. And you know what that means. That means there's a right angle at the point of tangency. Then when you, and put the 5 there, I almost forgot the 5. Then draw in the radius out to the end of the chord. That's the big radius of the big circle, and it has a length of 13. Now you have a right triangle. One leg is 5 and the hypotenuse is 13. So you must know what the other leg is. That's right, it's 12. But that's not what the question was asking. Make sure we answer the question. We need the length of the chord of the large circle. So that's the whole thing. If 12 is on this bottom half, then 12 is on this top half. And the length of the whole chord would be 24. Please pause the video and do number 12, then turn the video back on to check your answer.